Hello students, welcome to my channel Theory Math. Now solution to this question. The first thing you need to know is this indices rule that says that if I have x raised to power n m, then it's the same thing as x raised to power n times m. Okay, which we can write as x raised to power n or raised to power m. So it is actually very simple. So because of this, I will now say that actually 7 raised to power 2x could actually be written as 7 raised to power x or raised to power 2. So this is perfect. This is okay. So the whole of this equation will now change. Instead, I'm going to have 7 raised to power x plus 7 raised to power x or raised to power 2. And this is going to be 7 raised to power x raised to power 3. Now everything is equals to 14. Okay, now you see from here I can actually factorize, or better still, just to take away the indices part, let me say let y be equals to 7 raised to power x. Now as soon as y is 7 raised to power x, the equation will now become y plus y squared plus y cubed is equals to 14. Now at this juncture, I can decide to factorize, so that I'm going to have y into 1 plus y squared is equals to 14. Now, I factorize it to a particular stage where I'm going to apply some kind of a trick to just help me solve this question. Now, this is it. This is going to be y into 1 plus y squared will now be equals to either the product of 1 and 14, which is equals to 14, or the product of 2 and 7, which is equals to 14. These are the only two possibilities. Now, but the issue is there is that this possibility cannot work, okay? Cannot work. It will not satisfy the equation. Now, let me justify the fact that I said it will not satisfy the equation. Now, if I have y into 1 plus y squared is equals to 1, okay, then I have multiplied by 14. Now, by virtue of placing this, I can now say that my y is equals to 1. Then 1 plus y squared is equals to 14. But if y is equals to 1, then this will be 1 plus 1 squared, which will never be equals to 14. So you see, it doesn't add up. So I cannot use this because it is wrong. Instead, I'm going to use y into 1 plus y squared is equals to 2 times 7. This is the right one to use. This will fit in what I want. But let me show you something. Now, the order is important. Somebody will say, okay, why not 7 times 2? Now, this is it. If I have 7 times 2, now by virtue of position, what I'm trying to say now is that my y is equals to 7. And 1 plus y squared is equals to 2. This will not happen because this is going to be 7 plus, this is, let me put here is 1. Okay, it's going to be 1 plus 7 squared. This can never be equals to 2. So this one doesn't work. So because it doesn't work, let me take it off. What I'm going to do is I will now decide that my y is equals to 2. And I have 1 plus y squared is equals to 7. As simple as this. Now I have one of the solutions already that y is equals to 2. So we are done with this. Then let me come back to this. 1 plus y squared. Then I can put minus 7 is equals to 0. Rearranging it, I'm going to have y squared plus y, then minus 6 is equals to 0. Now, this is a quadratic equation that I can actually solve by factorization because it is factorizable. Now, how do you do that? You now multiply this. This is minus 6y squared. Then I will get factors of 6y squared minus 6y squared. I will sum to give you plus y. And the factors, will be plus 3y and minus 2y. So having it in the equation, I'm going to have y squared plus 3y minus 2y minus 6 is equals to 0. Then grouping it in twos, okay, what I'm going to have is to factorize further. So that I'm going to have y into y plus 3. Then I have minus 2 into y plus 3 is equals to 0. So I have y plus 3, then into y minus 2 is equals to 0. Okay, this is beautiful because we can conclude that y plus 3 is equals to 0 implies that y is equals to minus 3. Then y minus 2 is equals to 0 implies that y is equals to 2. Okay, now the three values are y is equals to 2 from the first one we got, and in this case we have y is equals to 2 and y is equals to minus 3. Okay, so we have two values here, 2 and minus 3. But this is what I want you to note. Recall, we are not to look for y, we are to look for x. So we know that y is equals to 2, not 2, y is equals to 7 raised to power x. So we'll now come down. When y is equals to 2, what I'm going to have is, well, I'm going to have that 7 raised to power x, is equals to 2. Now, once I have this, I'm looking for x. So the next thing I'll do, I will take log of both sides. And what do I now do with this? Is to say log 7 raised to power x is equals to log of 2. All right. So recall the logarithm law that states that if you have log of y raised to power n then base x, then this is going to be log of n then log like this. Okay, since we know this, then we'll come down to this. Hope you know that this is actually base 10, okay, because that is what it is. So I'm gonna have x log of 7 base 10 will now be equals to log of 2 base of 10. Now x will now be equals to log 2 base 10 all over log 7 base 10. Okay, now from change of base, let me show you this. From change of base, if you have log of a base b and you wish to change it to base of c, then this is going to be log of a base c then divided by log of b base c. Now this is vice versa, it could go either way. Because of that, we can conclude that x is the same thing as log of 2 base 7. That's the value of x. Now let's go to the next. When y is minus let me see, is it minus 3 now? Okay, good, minus 3. So we come down when y is equals to minus 3. Now what I'm gonna have will be 7 raised to power x is equals to minus 3. Okay, now from the look of this, if I want to take the logs, this is going to be log 7, then this is log base 3 like this. Now this on its own is not real, so it is not in the real plane, it is in the imaginary plane. It is imaginary. Hence, if I'm looking for real solutions, this will not be one of it. Okay, so since the question from the instruction in the question we have to look for the real solution, we will now have just our answer to be equals to that x is log of 2 base 7, because we do not want the imaginary part, we want the real part. Okay, now thank you so much for watching. I believe you enjoyed the video, so keep watching my videos for very good and convenient math classes and tutorials. Thank you so much for watching. Don't forget to subscribe.